Hey, okay, welcome back. So we're going to keep going over FumeFX stuff because in the last lesson we kind of covered the beginning, and now we're gonna look through the rest of kind of these system properties in simulation. Gravity does exactly what you expect. I mean, it kind of controls the simulation. So if you have no gravity, it'll just sit there not doing anything. So and buoyancy is closely linked to gravity. So if you took this to 0, then your fluid's not really doing anything. So it's not going to go up. It's not going to go up in space. Especially, this becomes apparent if we turn off the object's velocity. So we put that to 0. So now you can see nothing's really happening. And if we put the gravity to 1, the buoyancy to 1, which is how it comes in by default, then you should see this fluid start to naturally just rise, kind of like smoke would. So, you know, it's an easy way to get kind of control over some things when you just turn these off, and then you can mess with your fluid, kind of get it looking away, and inch these back up. You know, start small, inch these back up towards 1, or else you'll quickly lose control sometimes. Now, this is actually an older version of FumeFX. I don't quite know what version it is. I think it's FumeFX-2, but they've got like 2.1 or like a new version out, and it's pretty much the same. It's what we use at work, and I mean, it's switched some things around a lot. Like you can add negative buoyancy now, and like the buoyancy is actually down in like the smoke tab, but it's the same thing. So it all carries over. They just moved some stuff around, and they implemented like you could do different advection kind of techniques, which don't actually prove useful, oddly enough, but it's cool that they're there. So okay, that's then there's vorticity, which is going to refer to kind of how much this thing spins. So it's going to be hard to tell maybe at this resolution, but if we bring it a little lower, so now we have 0 vorticity. So what you'll see a lot of time in gas simulations are these kind of vortical like swirls, and that really relates to vorticity. Let's try the same sim with vorticity at 1 and watch how different the results will be. It's not dramatic, but you definitely get more kind of swirling motion naturally in here, and this can become very exaggerated at higher resolutions. And to be honest, the default value of 0.6 is great. I mean, you know, 1's really high. If you put this up in a higher resolution, this would just kind of look like noise, you know, and you can see there's a lot of detail going on there. And the vorticity was originally intended for these kind of lower res simulations because it makes that look really good. But once you go to a high resolution, that'll just happen naturally, so you won't have to worry about that. Velocity damping, don't worry about that. This is turbulence, so you can see you can unlink them, so you have Y turbulence, Z turbulence, X turbulence in separate degrees of intensity, but let's just stick with them all as one. So let's put this to 100. No, 10. And I believe this comes into a default of 20. So this will also come in the default of 1 here in the detail, and just turn that up because it's going to look good. If you're doing a candle flame or something, maybe you could keep it at 1. I'm sure it's a little faster maybe, but I don't see any reason why it's not just set to 5 automatically. So you can see now, look, our fluid is just totally getting a noise field run through it. Just like when we were messing with those particles. I mean, it is the same... It's the same thing that's happening to both of them. You know, they just kind of have different names, like, and the labels are different, but the principles and the movement is identical. So, all right, how can we change this? The scale, very important. If you're doing something like fire, you can bring that scale really lower. I mean, even lower than 0.5. You know, just get it. You get some really fine turbulence. I mean, it's not going to look like much here, but for something like fire, that can be really helpful. You see, I mean, it's just gross, but if we wanted to do kind of a bigger noise, bring this up to like 70, you'll see the noise will now just disturb it's basically just changing the frequency, right? So it's making, like back in particle flow, it's like taking that scale on the noise field and making it 0.03. You know, see how the noise is now broad. And the thing about FumeFX and noise, or turbulence in this case, you don't usually need it. In Maya, you know, if you're used to doing gas sims in Maya, it's really important because that is that's how you get the detail, but not so much in FumeFX, because FumeFX is really just, it kind of takes care of everything for you. Like it just looks good. You give it some interesting motion, and it'll just perform. So be wary of adding too much turbulence. You know, nothing wrong with setting turbulence to like 0.1 and stuff, just to get some breakup in there. But you don't need to go overboard with it here, or else you'll just get kind of a noisy, ugly looking simulation. All right, so that's pretty much it. You've got these blocking sides, which sound exactly like it is. Like you can make it a self-contained box, like a wind tunnel, like we'll make it a box, right? So both, and this can actually be really useful. Like negative Z, totally cool. Like if you got this set to none and none, and then we'll bring this to the bottom here, or no, we'll just leave it here. One thing I'm going to show you right now is the gravity vector, which is kind of cool. So it'll actually get dragged out. You can change the direction of the gravity in Fume this way, which is cool, so that you can animate that too and stuff. If you wanted, you can do it with negative buoyancy in the new one, but one thing I didn't cover also is this time scale. So time scale, speed up, slow down. You can keyframe this. That's how you make explosions. Oh, interesting. That didn't do what I thought. Let's try moving this like this. So gravity vector. So all right, now our smoke is coming downwards, right? And you'll notice we have it set to collide with the floor, which is kind of cool. And it's a really cheap way of getting ground collisions, which is neat. You just turn on negative Z, and you don't have to add in complex ground road geometry kind of thing. It'll get you the ground collisions for free. You can see it's just colliding with the bottom of the container, and that can sometimes save you a lot of simulation time when you know, if essentially your surface is flat, you're not going to know that every rock is not, you know, in the simulation of the ground and stuff like that. So that's a kind of cool way of getting some added performance. Okay, so you can see that we kind of scrub through this, comes down, hits the ground, which is cool. And that's just this blocking sides here. And timescale is really important. It's probably the most important attribute here, because it really can change the look of your simulation. It can also blow it up, which is a little fun to watch sometimes. So that's it at 10. You can see how much faster it's going, and yet it's just kind of falling apart. Keyframing that can be really cool. Like you can get a lot of interesting looks by keyframing the timescale. Definitely the only, well, you can do explosions with noise on planes and stuff like this, but it's probably better to try and keyframe that timescale at the beginning, so the explosion is very violent and then it kind of cools down, and you just got to be careful about how you ease that off. So yeah, that's pretty much it for the basics of FumeFX. I mean, there's a lot more to cover. I mean, FumeFX is a big tool. However, we'll cover some of the wavelet turbulence stuff in the next lesson when we get back into the tornado and how that works.